SpaceXplr episode. Today we have another great guest, and I'm very excited to bring you on today, Rashmi Shioran. She's what she is. She is a physics graduate from Delhi University. She's graduated this year, 2020. Currently, she works at Space on Nova as chief astronomer. Since past 2 years, she has been involved in various citizen science projects like Zoo Universe, IASC, Rad Home, and more. So, of course, we're going to include all the links for those projects in the show notes. So make sure to go and check them out. She does science communication on her Instagram and Twitter, and recently started producing science videos on her YouTube channel, Astro Roxy, which you have to go and check it out. Make sure to go and subscribe and leave a bunch of comments for her to let her know that her work is awesome, which it is. So, Rashmi, I want to say a big thank you for joining me today. I really appreciate it.
Yeah, thank you for having me. And that's a lovely introduction right here.
Thank you.
So, where do we begin?
Well, you tell us. You tell us about your personal beginning and your personal journey. I mean, how did you get started in astronomy in the first place, and how did you came across it?
Okay, for me, the journey was like I was fascinated with the big questions as a child, and I think most students are indeed fascinated when they think about the topics of what will be there after this life and how big is the universe. Are there other people, maybe outside Earth? So when I started to like in my school or anywhere else, when I was started taught the solar system, so this is a solar system, this is a galaxy, and I used to always question like what is outside a galaxy, how was the universe created. So even though I was so young, I used to have all these questions, and I did not know that astronomy is a field at that point of time, because that was just like one chapter in so many chapters in the science book, so nobody really talked about it. But then I like lost the touch with astronomy for a while. But then back in high school, I just came across TV shows like Cosmos, or the ones on National Geographic, or Stephen Hawking's, and these awesome shows, I would say, of science communication, and they were all talking about this astronomy and the big questions, trying to answer them. I just got so fascinated by it. Like, this is a natural thing. People study the night sky, people study the universe. They do not have to necessarily become the other subjects as well. There are which are there, like you can become a doctor, engineer. So all of these were the people who I saw around me, but I never had seen people who were astronomers. And when I came to know about astronomy, I just, it just completely took me away with it. And then I started going to astro camps, I started organizing them. And now what I do is I do science communication in astronomy, I do public outreach in astronomy. So telescope watchers, or telling them people how to watch a meteor shower or solar eclipse, like the one coming up. I even made a like video about it, like how can you watch solar eclipse even if it's not visible from your location. So I now currently I'm very interested into the citizen science aspect of astronomy, as well as the public outreach, because I think even though there's a lot of scope, that there are big questions and they can be answered, but the best thing we can do to make the students who do not know about astronomy is give them the dark night sky, give them an experience of a day or two, and then they can know more about it. Because if the night skies are not clear at the place they are living, maybe they might not be interested in astronomy that much.
Got it. So can you talk about
Yeah.
again, because before we started recording, you said, listen, I want to talk what's happening in India right now. And again, a lot of people,
Yeah.
I think they don't know, but India is very big when it comes to space exploration. And again, what you do guys with ISRO, and it's quite big space agency we're talking about, because a lot of people, when they think about space agency, they think NASA. NASA is the number one. And of
Yeah.
course,
Yeah.
because there's a lot of
Yeah.
budget goes towards that, and a lot of people know about NASA a lot, and ESA, and JAXA right now with all the space missions. But ISRO is actually a
Yeah.
great space agency, and established not long ago. I think it's 1969 that established, not long ago after NASA.
Yeah. Yeah.
So can you talk about what's currently happening is in space and astronomy in India in general?
Yes, yes. So when we talk about astronomy in India, so when we talk about the whole space science, so ISRO is basically focusing on not on particularly astronomy, but the other space missions, like going at
Mhm.
outside the Earth, trying to study either the moon, our planet Earth from the satellites, or going to the Mars. So these are the things that ISRO is focusing on, and there are a lot of technicians and engineers there, and they are doing a really good job. It's like when we see the numbers, like how much it takes for a rocket to launch from India compared to the money it takes for, let's say, for making a movie. So the budget is really, so it's like very cost effective. So even though the in India's budget, the budget is still very less compared to other countries because they get a higher percentage. The budget is less, but still it's progressing very, very fast because there are new missions. Like every 1 year or 2 year, there are new missions. So Chandrayaan 2, when it was launched, it just sent a huge wave across the entire country. Everyone was so excited that we are launching Chandrayaan 2, and there's an orbiter and there's a rover. So the rover might actually land on moon, and like the whole country was so excited, and even I personally was so excited. I was like, I want to see this rocket launch, and I went to go see the rocket launch, and the place where it was happening, it was so crowded. Like even the local people were so excited. They had traveled from many kilometers, and even though the like it was rescheduled, so many people came the second time too. They stayed for an entire week to watch the rescheduled one. It's like it was so crazy. And I think the upcoming missions, like there is Gaganyaan, so the upcoming missions like this in India, they are inspiring the students. Although they are inspiring in just one particular aspect of space science, the other one, which when we talk about astronomy, so to that to do, we need more observatories in India. So ISRO is not focusing on, let's say, making an observatory. They might make a vehicle, a launch vehicle, they make a rocket, but they won't make an observatory. So in India, I find that the knowledge or the institutes which might provide the space, the particularly the astronomy knowledge, they are not that much, or the competition to go into them is very high compared to other countries. It's like just right after high school. In other countries, you can go and study astronomy, but that's not the case in India. You have to at least study 2 or 3 years, maybe even 5 years before you can particularly start studying astronomy, become an astrophysicist. So the route is not that clear, and that is just one of the problems. The other problem is obviously, like even since a very young age, students are not told about astronomy as a field. So there are all the other subjects, but astronomy is not included in the like school curriculum. So that is something that really bugs me, because if students, they are told about astronomy in their curriculum and they study about it, maybe they have visits to the dark places, they will be developed in a way that they will not support the thing known as light pollution. So there is, like in all the metro cities in India particularly, there is a lot of light pollution. Students don't know how the night sky looks. Even though they want to see Jupiter from a telescope, they can easily see that. But when it comes to watching the same Jupiter from a place where there are no clouds, where there is no light pollution, the view that you will get is very, like very far away, very better. So that is something, because that is what I had personally experienced. I had lived in cities, I had lived in the dark locations as well, and I feel that if more students are given this access, maybe the students will be very enthusiastic to explore this field just because of the experience it gives to them. And yeah, like the school curriculum is obviously one thing that we need to improve, so that more and more students from a young age, they are encouraged to study astronomy. And the other things are obviously to make more observatories, because there are not many jobs when it comes to, let's say, becoming a science communicator in astronomy, or becoming an astronomer in a public observatory, or in even in a government observatory. So these are the things which are very less and they are rare, and only few people are having access to that. So I really hope that the situation gets better, both for the ISRO part, like for both going outside the earth from India, as well as the night skies are visible from the Indian locations. Even they get better, and more students have access to the dark night skies.
And what do you think would be one of those quicker solutions for people to spread the message and let people know, look, there is for you ways that you can get involved with astronomy and again be a sky observer, again work in potentially observatory as well, and maybe something to do with space engineering, because I mean there's a lot of engineers coming from India as well, as far as I've
Yeah,
heard.
yeah.
So
Yes,
what
yes.
So what about spreading that message? What would you say? Like, what is the quickest solution, and what other solutions have you looked at to reach more people?
Okay, so one of the solutions is obviously making it a public thing. So let's say if we make a lot of movies. So in India, in Bollywood, I think the highest number of movies produced in entire world are maybe from in India in a single year, because Bollywood produces a lot of movies. But they're particularly like some other kind of entertainment movies in which they don't show either the science, or let's say because they're focusing on astronomy, they won't even talk about it. Their focus is just something else. They're talking about other aspects of life. So I think if topics like astronomy or light pollution or going outside Earth, so if these kind of space science related topics are made into the popular media, maybe through films, maybe through like TV series or anything like that, that would be a great way to encourage and to reach the public. Because all of the it doesn't matter if you're a student or if you're a working class or if you're just living in any spectrum, you might be consuming some media. And if we show like some things related to science, or if we talk about science in this, that would be a great way to reach the students as well as their parents and the people who are working in the government, the teachers, all of these people, so to create that ecosystem. And one of like one thing is really happening in India. So they have opened a new channel that is like online TV OTT, I think they call it. So it's like 24 hours there will be some broadcast happening, and students can go and they can listen to things related to science. So it's like India Science TV, and then they can listen all of things, not just astronomy but other things happening. And that is a really great initiative, but it's not popular. You won't find that app in everyone's phone. But if we can make it popular as, let's say, Netflix, then that would be a really great way to reach the students, because many students have the app of Netflix and they watch it daily, but they don't use the other app that is released by the government of India. And if they can do that, if they can reach the students, maybe through marketing or anything that Netflix does, so that would be a really great way to reach the students. So that is what I think. And I think for that aspect as well, we need more people who talk about this openly. So there are a lot of journalists in India, but they're not science journalists, they're not science communicator. In media, science is not that much. So we talk about pseudoscience, we talk about religion a lot. So that is highlighted. The clickbaits are highlighted. All those things are highlighted more than the actual science, the actual facts. Nobody talks about them, and they see it as maybe boring, or they don't relate to it, like science is not part of our life, but these other things are. So they do not see it as their part of life. But if they see it in the popular media, maybe their mindset will change.
Got it. So I love the fact again. I love the Stephen Hawkins quote that you have on Instagram. It says, "Remember to look up at the stars and not down at your feet." So that's good.
Yes,
That's
yes.
a really good quote. So what would you say to the people part of that looking up? Why should more people to look up at the stars?
Yes. So one thing, again, I would try to bring that point out, that if you look up, you should first thing is you should see the stars, because if the stars are not visible, that is not a great thing. Like you're looking up and you see just the planet, you see Mars, you see Jupiter, that's it. But you're not able to see the Orion constellation. You're not able to see anything else. So this quote is applicable to a greater degree if the stars are visible to you, if you can see the constellations. Let's suppose if you look up and if you see the constellation of Orion and you see the Pleiades. So if you know about the mythological like the stories that were related to it, you can attach yourself, or you can try to imagine how your ancestors used to look at the stars and what they used to wonder. Because these kind of things will always fill you with wonder. Like these people, let's say somebody from 1,000 years ago, when they used to look at Orion, they make a story, and now it's very popular among us. Like we call Orion the hunter, or we call Pleiades the seven sisters. But now we have the images of the Pleiades, and we know that how many stars are there. It's a star cluster, it's blue in color. We know how nebula looks. We know how the stars in Orion Nebula are so many light years away apart. Like some are just 200 light years away, some are as much as 1,300 light years away. So we have all this knowledge, but it started from that many years ago. So astronomy is a really ancient science, And if you look up at the night sky, maybe you can try to connect to that it's so ancient. Humans are exploring and trying to find out these big questions, answer to these big questions, and now we are so far away. So I won't say like our normal daily life problems are less significant, but it just fills us with a lot of awe and wonder, and maybe like kind of relax us down and fill us with more maybe imagination or creativity, or just give us some hope. Like we have came so far, we started so many years ago, and humanity is really advancing in trying to understand the universe. So maybe those kind of things, because you should not look down at your feet because you're not sad anymore. If you just look at the stars, that's like the stars are shining for you, they're ready, that you just need a telescope, you can look at the stars, you can find out there are so many rings in the Saturn. There are like binary stars. Maybe if you observe Betelgeuse, you will see that the brightness is changing of Betelgeuse, but that's not an act of God. Nobody is really messing up, so no God is angry with you, but that's just Betelgeuse. It's maybe near the end of its life, and you have all this knowledge. It's not easy to get access to this knowledge. And if you are inspired by these things, if you are amazed by these things, so that would be a really great way. And again, as I say, if you have a clear and dark night sky, that would be possible in that.
Got it. One thing that I wanted to ask you again about these projects that you mentioned is Zoo Universe,
Yeah.
ISK, Rad at Home. So can you talk about these projects and what they've been doing to bring more attention to astronomy and space overall?
So I would start with the Zoo Universe. So it's a platform. Basically, so what the platform have in common is the citizen science approach to them. So what is citizen science, if somebody asks? That's like citizens are doing the science and they are contributing to the real research, the real problems that are there in the science, but they not necessarily have an institutional degree with them. They don't have the 10 years of experience with them working in the field, studying the same things, the same kind of objects for several years. No, they're just like all of us. It can be an artist, it can be a painter, it can be a singer, it can be someone, anyone it can be, and they can do science. So that is the basic, the whole of it. Anyone can do the science that comes in the citizen science projects. So the most famous one, or the most widely known one, used one, is the Zoo Universe or Galaxy Zoo. They have a website and they have many projects. And in particularly in astronomy, or just when you look about either observational astronomy, like they are they are showing us the data that let's say Kepler telescope had seen a lot of exoplanets, but they have not really detected them now. And if a student, if you're taking an example of a student, they don't know what are exoplanets, they don't know how to detect an exoplanet. What are the things needed to be categorized something as an exoplanet, because they would be getting all this information by years and years of studying. They won't just really know it in just few minutes. But
Mm.
what Zoo Universe does it, they present this information in a very simple way. So they will just tell us simple things like, okay, these are two lines. If you see a dip in the second line, that means just just tick yes or no. If you see a dip, just tick yes. If you don't see any dip, just tick no. And even just simple things like that, even the person doesn't know what is an exoplanet or what is a transit, or how can they, how is this dip possible, what is the wavelength that we are observing the dip. So they're not aware of all this information. They just know that there are two lines, and if there's a dip, they have to click yes. And what happens is, when several citizen scientists do it, and they are analyzing, let's say astronomers are analyzing the data, they can easily see that a greater bunch, let's say 90% of the people have told that in this particular star system there we have observed a dip. And what they can do is, rather than observing one star one by one star system, they can just directly go away to the star system which has 90% votes that yes, there is a tip, and they can just go there. And luckily what can happen is, they will find really an exoplanet there. And that is very fast. If you talk about it, like, so many people, if thousands of people say that there's a dip, that means 900 people have said it, and they cannot be just mistaken so easily. So rather than the astronomers analyzing one system at a time and like trying to get lucky or unlucky, they can use the power of citizens, power of the number, and they can like prioritize the systems which have a greater chance of finding an exoplanet. So that is an example, and there are many projects on like many in all areas of science, not just in science, like in many areas. There can be literature, there can be art, there can be something related to what happens when a tiger is sitting with their children, something related to that. So there are many, and I have taken part in some of them. Particularly, like I was very interested in the data that was by Kepler Space Telescope. Now that was something in these. The other project was which is called IASC. So what we do in that is we detect asteroids. So similarly, we don't have to know much about what are asteroids and how, but we know like asteroid might be a space rock, and if it comes too close, we might be in danger because it can crash and it can create a very great impact. So one thing we can do is we can have a lot of number of citizen scientists, and they can try to detect what is a space rocks and how does it look. So similarly, they will have a criteria, like if you see something going through the sky, when you blink the images, you might see an asteroid. So just click enter the data and just click on it. That's as simple as that. It won't take much time. And obviously, like every year, I think 2 3 asteroids are detected this way, and they are then the data is sent to the astronomers, and they try to detect them. They add them in the database, and it helps so much. And similarly, in India, we have a project called RAD at home. So that's real astronomy discovery at home. And in that, similarly, it's one of a kind of citizen science project in India, especially in astronomy. I don't think there is anyone else expect them. And they have been recognized by various platforms. And in that too, so like the teacher tells us about how you can detect something fuzzy, something strange in this data. They will teach us. They have some classes, and then we can start performing more and more. So even though like the level of what we do is a bit more advanced in RAD, but still it's the same approach that anyone can like really come there, and they can try to start analyzing things even if they are very young, at a very young age. They don't need to necessarily have a lot of years of experience, and whatever they do, that will help the scientists in making their work like faster or more efficient, things like this.
So what about some future, citizen projects? Is there anything else that you have in the pipeline that will be coming up in the near future for citizens available?
Yes. So as I talked about, even in my introduction, you mentioned that Space Innova. So what particularly I'm doing at Space Innova is I am heading the astronomy department. So I had the science communications and the citizen science project. All of these things related to astronomy in Space Innova. So we are really coming up with ways, either collaborating with the existing citizen science projects, because in India, not many students know of the citizen science project. So if they're not even aware of this, how can they participate? So the first thing would be making citizen science a bit more popular, or at least accessible in India, so that students know that there's a thing like that. And if they cannot find it in mathematics and physics or in any other subjects, but particularly they can at least find it in the space science sector. And we are hoping that we can start something on our own. So maybe detecting something like again, we can have like telescopes, and students can observe the data of these telescopes and try to find something new that is unusual in the night sky. Or even they don't have to necessarily find something new, but even if they look at Jupiter for many days, and if they're looking at Jupiter and they might see that the red spot is suddenly growing a bit in size or decreasing a bit in size, even that is part of the citizen science. Then they can report that data to a big observatory, and they can try to analyze like what is happening on the surface of Jupiter or in the atmosphere of Jupiter. So that can really help the scientists to find these small things that maybe they might miss if they're looking or doing work on the other projects.
So when it comes to astronomy, I mean, there's a lot of different subjects, and there's a lot of different ways that people can get involved with all these different projects. So what will be kind of your favorite projects and topics when it comes to astronomy?
My favorite would be the big questions. The biggest questions of all that is what I like. So there are theories like Roger Penrose, who recently received a Nobel Prize.
Mhm.
So he had been working on a theory called the CCC, the cosmological conformal cosmological the cyclic conformal cosmology. So, and what he talks about is the whole universe, and how there's a possibility that there might be a universe before our universe, and there might be a universe after our universe, and it's a long cycle, and it will just forever keep on going on. So I really like in cosmology we talk about these big questions, and we try to do the math, and we cannot really observe all of these things, because even if he has some evidence that this theory is correct and he has observed the things that he predicted, but still he cannot be 100% sure that there was a universe before our universe, because it doesn't matter how much the data is there, it's just so difficult that to get that level of confidence in the data, but
Yeah.
still they're working on it. And that is what makes me feel like, okay, I also want to work in something like this, either studying the galaxy morphology, like how the galaxy have evolved, because there are so many shapes of galaxies, and when I look at the images of, let's say, Hubble Space Telescope, I'm like, okay, one galaxy is a spiral, one galaxy is not a spiral but it's crashing. So I try to ask questions like, what would have happened to a galaxy that its shape has changed in this particular way? Was it always like that? Maybe it had a collision with another galaxy, and that's why it is like that. That's why its the present shape is like that. But how will we know? Like, we have the data, we have the image, but how would we run back the data and do simulations and find more about these things? So that is something I'm really interested in. But that is more of a, like, I have interest in that, and maybe I will try to explore this interest with the help of citizen science. But particularly currently I'm focusing more on the science communication side, so reaching to more audience, or just more students or people who are interested into learning about astronomy in, let's say, not from textbooks, but from either watching videos, watching some people talk with their discussions, so people who are interested in learning astronomy through these mediums. So that is what I'm focusing currently on.
Got it.
Although, yeah,
So
yeah, yeah.
any space projects that ISRO is working on? Again, you mentioned Moon Rover, and there's a lot of different exciting
Yes,
stuff.
yes.
But in the next 5 to 10 years, is there any projections of the future space exploration?
Oh, yes, there are many, because as I said, like, I am more interested and updated about the astronomy department. So yeah, the one that I know of is they are working on the Gaganyaan mission, which might be launching next year, like the test mission. Apart than that, what they're working on is making a space station, Indian space station. So that was like something really exciting when I came to know about it, because then astronomy astronauts, the jobs, like, people can become astronauts in India, because if you see right now, I don't think you can find the students saying that I want to become an astronaut, because how can they become an astronaut if there is no need of an astronaut? Because we're not sending astronauts to space right now, because there have been so many years of gap since the last astronauts that India was sending, and that too, the astronauts were going to the other countries and launching from there. So in India particularly, nobody is currently, if I talk about currently, except the Gaganyaan mission, they're not really astronauts. So people are training, but they cannot say like, I'm an astronaut. But if we have things like a space station, an Indian space station, going to either the moon, or making something making missions just to the ISS, not the ISS but the Indian space station here. So there can be uh, you know students can say that, okay, I want to go to the moon, and I'm an Indian, and I'm an Indian astronaut, so that they don't have to go somewhere else. And that, I think, ISRO can really pull it off. And there are also private space companies in India really popping up. So since last 10 years, 15 years, before there was like only ISRO, but now even ISRO is trying to approach these public private companies, and they are trying to step up and build their game. So in the next few years, maybe ISRO and these private Indian companies can collaborate and try to send either the humans to space or to other planets and do some space exploration, just like how the other countries are doing. Because recently, how SpaceX has evolved, and there were no private companies before that who had received that much, but now SpaceX is like, they are sending astronauts, they are sending cars and whatnot, like the recent Starship, the mission that that they were trying to do. So I think that really inspires not just the government agencies across the world, but even the private agencies in India. That is something that people should really look out for, because there are private space companies in India that are popping up and who are focusing a lot on these aspects. And even like there are some public observatories. So even in astronomy, something is happening, but it's still not reaching at that stage like it can be compared to the other countries. But still,
Mhm.
it's getting better and better.
Good, and that's very promising and good to hear that more people are getting involved. Which which I'm actually seeing exactly the same thing. I think it's a lot of it is trendy. A lot of the
Yeah,
stuff
yeah,
is very trendy. So I don't know how does it work in India, but when you're gonna go to the local shop in here, and maybe during the COVID, I don't know where you guys are. Maybe it's gonna be
yeah,
closed. So for now, it's
yeah.
open. So if you're gonna go to the local clothing shop, you're gonna find these.
Yes, yes, yes,
That's
yes.
what you're gonna find. So that means there's more attention going to that, and of course part of that maybe it's a trend, it's a fashion and whatever. But at the same time, there is this subliminal message for the people is like, okay, so what is NASA? What does NASA do? And what's other ways that maybe I can get involved with that? So I think it's very great time for astronomy in general. So what are your personal thoughts again? And you mentioned SpaceX and
Yes, yes,
just like yesterday, a couple of days ago, we had the Starship,
yes,
test
yes, yes.
test run.
Yeah,
So,
yeah.
what do you think about Mars? And overall, is it a good idea for us to travel and colonize Mars? And what do you think is going to happen? Is it going to be doable, not doable? Where does it take?
Yes, yes. So, yeah, going to Mars is one thing, but what I spend my time mostly on is trying to think about thinking about aliens on other planets, like how life might be on other planets, not just in our galaxy, like just out there, how it can life might be. So, like again, all these thoughts were really inspired by when I used to watch the popular science fiction, and I'm watching all sort of aliens they portray us. But when it comes to Mars, so obviously, like there are these things that Mars currently is not that much habitable, because it's mostly dry, except for the things that there is ice somewhere. But mostly, if we are going to Mars, we might not go there to live, but we will go there to explore, maybe to learn more about how Earth has evolved. Because Mars, in the past years, past thousand or more than those years, million years ago, Mars also had might have had water and atmosphere, but now it has turned all dry. Then it's not impossible for that to happen on Earth, even without the nuclear weapons. That can actually happen on Earth after several million years. So if they go to other planets, maybe not to live, but just to explore how Mars have changed, and they can learn more about Mars, and that will be like a step up. And then they can say, okay, now we have gone to the Mars, we have gone to the moon. Now we can go to locations in our solar system where there is a hint that life might be there. So they might try to visit a moon of either Saturn or Jupiter. They can say that, okay, we are launching a mission to Europa, and we want to see what is there beneath the ice. We are saying that there might be liquid water. Let's see a rover or something like that. Let's just send a spaceship. And so that will happen only when we have that's like a ladder. First you go to somewhere in the space, then you go to the moon, then you can return back from the moon, then you send rovers to the Mars, then the rovers will return from the Mars, then you can send humans on Mars. Then you can think about the bigger things. Then you can try to send rovers on these planets, which not planets but moons, which are very promising of the Saturn and Jupiter. And maybe after that we can try to think about the big things, like sending something, anything. It can be either human or babies or something, babies in spaceship and to other planetary systems which are around us. So something far away beyond that solar system. So we can only think of those things if we try to explore the things that are around us. So first going to the moon, then Mars, then to the other moons of other planets. So I think it's like a ladder system, and you have to cross one thing to reach that point. Because when I think about, okay, if somebody is sending us a signal, how will we try to identify that? If somebody comes from outside, it is a particular, like anything we have never seen before, a new species of aliens, how we will try to contact them. And we cannot really do anything about these things till we have some knowledge about what's happening on the worlds that are around us. So I'm very optimistic that humans will be stepping up on Mars before in my lifetime only. and I'm very excited to see what happens, because I was not watching when humans went to the moon. I think yeah, I wasn't watching. I just like I grew up and I knew, okay, Neil Armstrong was the first man to step on the moon. That was like an information that I studied. But now in my youth I can say, okay, I'm waiting for someone to step on the Mars, and that would be something that I would be witnessing. And I think that is a very great thing, because I really want to, witness and feel all these things, that humans are going to the Mars, they're stepping on the Mars before they go anywhere outside. So I'm very optimistic for these things.
Got it. So at the same time, you're still gonna see the moon landing mission also with the Artemis program. So you're gonna
Yes, yes,
see
yes.
so you're gonna see the moon landing and you're gonna see the Mars landing. So
Yeah,
two things.
yes,
Good,
yes,
good.
yes.
So
And
so
I'm
what?
gonna see Indians going to the space and all of those things too. Because I really hope not just in India but in other countries of the world as well. Maybe more and more countries can, because there are so many students, and I would just say people who are thinking that, okay, we want to do a spacewalk, but they cannot really do it. Just like we have citizen science, where citizens can come and take part and contribute in the research. I think people are working and making these things more privatized, and they will be like, okay, you can go to the moon. This is the cost, but you can go and live to the moon. This is the cost, you can go and live to the Mars. So I'm even optimistic about that. Like, first that thing happen, then people who really hope, that they just want to, go and look at the Earth from a distance point. Maybe those things will be even possible after a few years, after we have explored and we are confident about these things, and we have sent several missions. Maybe we can, bring those things, like maybe we can commercialize and make those things possible for the humans who really want to experience those things.
Exactly. Yeah. So hopefully. So what do you think right now with the rate of innovation that we're having? How many years do you think personally we should expect before we're talking about exploration of Europe or exploration of some exoplanets or outside of our solar system? How doable is that? How many years we're talking about? 100, 200?
Okay, I would definitely go with the like the big people who say that it's not that soon happening, because I was watching a documentary and I was seeing how one space rover was there, Cassini, and how it took so many years to just launch it, and it has such a, background story to it. And that thing, if I talk about, let's say, if you talk about the example of James Webb Space Telescope, it has been so many years. Like, I'm waiting for it to just go in space, and I want to see the pictures of it, but it's not happened since past 5 years since I came to know about it. Like, there's a mission that it's a greater mission. It will be going, and any year it will be there. So I'm following James Webb Space Telescope since many years, but it's not launching in space. It's already delayed so much. And there are, people talk about, like, will it be ever launched or not. It will be, taking 80 years, 100 years to launch. And similarly, I think there are so many missions to, let's say, if even if there is a mission to Europa, firstly, all the other missions to Mars and the nearby, let's say, missions to Venus, first they will be accepted. The farther ones won't be accepted, simply because there's not that much money, or maybe they're waiting for some other agencies to send their things first. Once that has been crossed, I think at least it would be, more than 50 to 60 years before we can even think about sending a rover to any of the Europa, or the other planets, the moons that are there. So that would be a really long time. And if you're thinking about going to explore the boundaries, near the boundaries of solar system, so maybe near the Pluto and those things, maybe it might take like 200 or even 250 years. But one thing I want to point out is how astronomy has progressed in the last 400 years. Like, there were no telescope before 400 years, but just, in just 100 years, the design of telescope changed so much. In the past 100 years, like, we have gone from telescopes on Earth to telescopes in space, and now we're thinking about something like James Webb Space Telescope. So I think the technology advances more than we can think of. So even if I'm saying that it might take, 200 years to send a human to just, just they are going to Pluto just to chill, that might take so much time. But maybe the technology will advance so fast that in just 100 years we might be, going to the different planets of a solar system. So it might advance, but till now, how I imagine things, because it has been so many years and humans have not stepped on the Mars, because there's a big thing about the funding, like who will pay for the travel to happen, the trip to happen. So once we figure that out, once more people are confident and they want to explore the at least our solar system, I think they will be, funding these things more, and the future missions, they will be happening more and more sooner. So that's how the technology can improve in the next 100 to 200 years.
Got it, got it. So again, you spoke about a very interesting subject which a lot of people get asked. I'm sure you get asked that question probably from time to time. A lot of astrophotographers get asked that question. Basically, all the people that are getting involved with any space related projects, they get asked that
Yeah.
question. And the question is do you think, is there something out there? You mentioned about some sort of an extraterrestrial human being like things. So what is your personal take? Do you think, is there something out there, or we kind of just alone in this vast of the universe?
I really think that there is something out there. Like, I want to believe on that thing, and I was telling you to, like, like, thinking about going to Mars and sending humans to Mars and there to do some exploration there, that is one thing. And the next thing that I focus more on or think more about is how there might be life out there. Because when you start thinking about the different possibilities, like, if you, there's no bar at all, like, there, because there is such diversity of life, at least on, even on Earth. So there are things, or I would say living things, that can live without water, they can live without the specific temperature that humans live in, they can live up, if there is no food, no air, no atmosphere, they can breathe in things that we're not familiar with. So there is such a diversity in features, the extremophiles on our planet. It makes us think that life on other planets won't be that difficult. Like, it can really happen if they just have few things. Life can really evolve out of there if we try to, make life not out of carbon but out of silicon. So it's difficult for us, but it can really take place. Maybe that's their normal, and carbon is not a normal thing for them. They can, breathe in the other stuff, or maybe they don't even need to breathe things, they're just alive in some other form. They can just breathe in the elementary, or not the elementary, but the very very small particles, which we are not even aware of, which are like virtual, which we cannot detect. So it can be in that scale, or it can be very big and or very small. Again, we are not sure about that. And again, there's a popular thing known as Fermi paradox on this, which say that even if the aliens or the intelligent life is out there, we might not be sure of how to contact them, or how to say that, this is a life and this is something which we can categorize as life. So even if there's an example that Earth, there are different cycles happening on Earth. So you can see that if you take the example of ice age, so ice age comes and it goes and it comes again and then it goes. So if you see that from a bigger point of view, you can say that this Earth is a living being, and the ice age is like, let's say, it's sleeping and then it's waking up and it's doing its whole thing. And the Earth itself a living organism with all these things, revolving around them, just like we have cells in our bodies. If you try to have analogies like that, you will be like blown away completely. You you will have so many things, thinking about how diverse the alien life might be out there. Not just life as we think of it, like eyes, nose, no, nothing at all, like of life itself that we are not aware of. Life
Mm.
can be there, as huge as a star system, so big. So there are so many possibilities, and that really blows me away. And I keep thinking that how humans are going to make in contact with life, because it will be just so different than we have seen before till now.
Yeah.
So I really do believe in like those existence of extraterrestrial life. It's just we have not able to find it yet, but maybe someday we will also find it and make a contact with it.
Exactly. So if there's something out there, we're gonna be aliens to those things as well.
Yeah, yeah.
So
Yes, yes, yes.
because we think, because again we have Voyager and Voyager 1 and 2, and we sent
Yeah,
this gold-plated disc with included
yeah,
mathematical DNA and our structure and the music and everything about our cultures, for those
yeah,
things to understand who we are. And we somehow
yeah,
think that everything, because scientists, at least on this planet, through a generation of evolution and everything that we have with the books and information and the language that we speak and everything that we put out, all the information, we think that universe is once they will receive the message, we think like these people will understand the message, because we think that universe is all just numbers and statistics. Like we don't have a clue. As far as I think,
Yeah, yeah.
we don't have a clue. Is these things are gonna take the information, or maybe they're gonna be looking at and thinking like, what is this? You know, because we think, okay, we're just gonna put it out and they will understand. Like we don't have a clue what we're doing most of the time, because
Yes, yes, yes.
we're so behind like what's happening with that. So but it's good that we're making those space projects happen. So again, I'm not sure, you know, is it the right thing to do, if it's not the right thing to do, but at least we're trying, at least we're trying to
Yes,
figure
yes.
something out, which I don't know if we will at some point, because uh I mean, the universe just continues to expand, creating new, brand new big bangs and new galaxies, and everything is expanding. And our innovation rate with the expansion of the universe is just like this, you know.
Yeah, yeah.
It
It's
doesn't
it's
go anywhere.
almost like negligible. Yeah,
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 it doesn't go anywhere, you know.
yeah.
So I'm not sure if we're going to be able to accomplish anything that you want, that we want in the future, hopefully. But so what will be
At least
again?
we're trying to explore.
Exactly. At least we're trying. So
Yeah.
that's a good thing. So one of the things that I wanted to ask you about IASC, you mentioned that you
Yeah.
do a lot of kind of asteroid observation with that.
Yes, yes, yes.
So I
Yes,
want to
yes.
ask you about a recent thing that I came across, and I have a few conversations with the people about 2036 Apophis approach. So what is your personal take on
Yeah.
that one?
Okay, so my personal take on that one would be like the possibility is really low for that asteroid to come near us or to hit us at least. So, but one thing we cannot be sure of is because there are so many other bodies in our solar system, they can really influence the path of that asteroid and the observations that we have currently. So we're saying that it won't reach or it won't be coming here, but it will just really have a really close by with the Earth. But what can happen is there are so many other asteroids and the moons of, let's say, Jupiter is revolving, so many of them, like 80 plus there are there. So they can influence the path of the Apophysis asteroid. And there is a situation where it might actually hit the Earth. And if that happens, we don't say for sure like what will happen on Earth. It can just strike us. I was even watching like what plans do we have if an asteroid comes near to Earth, because it's a really big asteroid and we cannot do much about it. Like how can we get rid of it? If we have to even pinpoint a location, let's suppose it is going to come in this particular place, depending on the trajectory, how they will leave the home and they can go outside, or which agency will step up and they will say, okay, we are taking the responsibility and we will try to either deflect it, break it, do something with the asteroid, or like how will all of these things happen out. So humans don't really have a clue when it comes to asteroids, and I would say no other species have a clue because they cannot do anything. At least we can do something, and one of those things is just being aware that there are things that can happen. Like an asteroid impact is not that rare, it can actually happen, and when it happens it can harm the human beings, it can harm a lot of population of human beings and the resources that we have. It can just cause such a grave impact, because just a small virus has caused so much problem entirely across in entire the whole world. And if something like this happens, it will again disrupt the economy of even a one state of the country, and it will just
Hmm.
disrupt the whole thing. So until we have more and more of these, like till more and more people try to find the smaller asteroids, the bigger asteroids, and then maybe we can pressurize the agencies, like make a mission and do something, like because even if the apostles won't hit us, there might be some other asteroid that we have never detected till now. It's just coming so close, and it's just that our telescopes are not pointing that way, so we have completely missed it. It's there on the blind spot, and it will just come very very near to near Earth, near the Earth, and we just have, let's say, 5 days remaining. We just observed it, it's just 5 days remaining. What can you do then? So one thing would be definitely that humans should be aware of the hazard, and that asteroids are really a danger, just like nuclear weapons. They are a really great danger. And even though we have some things, like we have settled the whole nuclear thing, and nobody is really trying to take advantage of that. There are not fights regarding that. But if an asteroid comes, we cannot do much about it. It's like it will just harm a lot of population and the economy and all of the things. It will just create something sort of like the situation which in which we are living now. where we might feel helpless, like say what scientists discover the asteroids, what were the odds, why did it touch the earth, what was happening with the scientists, why did they not tell us? So maybe they will blame the scientific community then. So I really hope that it doesn't touch us the earth, the numbers are correct, that it will just leave the earth with just a few kilometers. It's not coming that close to the earth, and we all are safe because we don't want an asteroid impact on earth, on any place on the earth.
Yeah. And one of the ways we're looking to prevent that from happening is next year, July, we're going to be launching a DART mission, which is going to be um, one of the asteroids that is out there. I think
Yeah.
it's probably is in one of the asteroid belts is Didymos or something like that. So it has a moon. So basically, this probe is going to be set to redirect the course of that moon and see if we can actually protect in the future, because that's going to be used for more of a defense
Hmm.
against asteroid collision with Earth. So we actually we're looking for ways, but we're still testing things out.
Yeah.
And again, with the rate of
Yeah.
innovation, again, it might take very
Yeah.
long time, but hopefully, hopefully.
Yeah.
So
And
what?
what is the success rate of we humans deflecting this? And then this is just a one lucky mission that because I don't think this many people can be really sure of that we are sending all of this money we have invested in this as this this mission is going trying to find an asteroid and attach itself to it, try to deflect it. This is a really rare mission that has never happened before.
Mhm.
But seriously, after the results come out, and if it's a positive result, I think more missions will be like that. And maybe we might take the like an asteroid impact more seriously, and we work towards it. Like we just need to have something to protect ourselves, even if the dinosaur did not have anything, other previous humans, nobody had anything, but now we have the technology. If we try to use it in the same way, maybe we can get lucky, and we can actually detect all of these asteroids that are coming and try to like save ourselves and save our planet from it.
Got it. So, and one of the things again that's happening right now with this current rate of innovation, we have a lot of, because again, we do need the internet connection, and it seems like mine could be a little bit better here as well. So, one of the things that I
Yeah.
wanted to ask you, because again, what's happening right now with SpaceX, they're kind of pioneering when it comes to making the space accessible and flying to Mars. And another thing is launching many
Yes.
satellites into near orbit. And we're talking about, I think the
Yes. Yes.
last number that I got was like 520 satellites additionally to the number that we have a year. So what do you think is going to happen
Yeah.
with
Yeah.
that in the long term? I think is it something we should pay attention right now in the future, and do you think it's going to be good or bad?
Okay, so it really comes down to what is your priority? Like, if you're sending these things in space, of course, everything has a setback to it. So one thing, as I can say, as they really come in the way of doing the research from the Earth itself. So what happens is all these, when these satellites are moving here and there, what really happens is if an observatory is dedicated that it is looking at the same point of sky for many years, it has just told that it will be measuring this point of sky for 10 years, and it's just taking such precise data. And if the like no aeroplanes, nothing is flying in that zone, but these satellites are just the satellite train is just trying to go in those numbers and trying to ruin the picture. So what will happen is, because we had done and invested in this observatory trying to take image, and now these satellites, because the number is so great, even if the paths are even if we try to make their orbit in a different way, they will somehow try to clash with the observatory's view. And that has even happened. I'm not getting what was the name of the observatory, but there was one observatory which was working, and they had sent the data that today, after this many years, we have received a picture, and in this data we can easily see these satellites. And this is like completely a fault on Elon Musk's part. Like, why are the satellite causing such a problem? We are making such precise calculations, we're trying to detect something new, and because of these, our data is getting ruined, because the different exposure settings, all of that is getting ruined because of the reflected light from it. So I really think is, even though it's a good step that everybody will be getting and an internet connection and access to the internet connection, maybe wherever they are living on the earth. So maybe that will bring some equality on earth, but again, that has some consequences. And because of this whole thing was just sent in space without sending some trial missions, because they should be aware that these things can harm the people who are doing either the astrophotography just for their hobbies, or who are using observatories and then doing astrophotography for some research. So that is something that I got a bit bitter on, like why are these, they're just sentence pages like that. But a good thing that is happening is, they will be again, if all things is good, everybody will be getting an access to the internet, and maybe like all everywhere humans on earth, they can be, they don't have to leave their location to go to some other place, try to get the facilities like internet or something else. They can just live at their place, and they can do whatever they want to do from, like, they're just their home. So that is something very good happening. But then again, just because this is a very great thing, then again there will be causing more and more space debris, because if there are thousands of satellites roaming around, there's a chance that it might crash to something else which is not currently operating. So the satellites that are not currently operating, and they are just sent here and there in space after they were decommissioned, so maybe it can easily crash with those things, and that can just harm so much things. So, and even like after some years, these satellites will also stop operating. So what will happen to these thousands of satellites additional to the ones that are already in space which are not working? So I just think that this, for the short time, it's a good thing. In just a few years, we all will be getting the things like internet. But then in the long run, we have to do something of these satellites. Like, we have to do something before we can go out. What if we're sending a spaceship and something crashes? Like, what will happen to that, to such important mission? So that is something that we should have a backup plan. Like, what will we do after 100 years that these satellites are not in use?
Hmm.
Because that's just such a huge number, like thousands and thousands. Yeah.
Exactly, exactly. So as
Yeah.
far as probably you guys maybe heard the news, because this year, 2020, there's been a few announcements that ISS, the astronauts that have been in ISS, I don't know the exactly number of them. I think because most of
Yeah.
the time they just stay a few, let's say from couple to 7 or maybe up to 10 people. I don't know, but
Yeah.
at that time,
Yeah.
they got a message that they should stay in a Soyuz, capsule instead of emergency landing, because a few times, I think it has been 3 times that's been reported that the debris that was in the atmosphere almost hit the ISS. Well, I don't want to say almost hit, but there was a warning sign
Yeah.
that that could be potentially
Yeah.
happening. So we're talking about this year. And of course, I think these numbers will go from 3 to 5 to whatever. Hopefully not.
Just
But
they will just exponential. Yeah, that would
yeah.
be an exponential increase, because the number, all the countries are trying to send more and more satellites. They don't want to depend on the other countries and their technology. So all of these countries, like even the private companies, want to show their power, and all of them are sending into space without thinking about what will happen after 50 years, when we just have so much of this, what should I say, trash in space, which is not helpful for us, because they cannot bring it down on Earth. It's not useful. So maybe again they can try to make something like, reuseful, or things after a satellite is not in use. Maybe they can have a mechanism that it will come back down to Earth, and they can, uh, just try to reinvent and then send it, that thing, to space again, rather than sending a new one and sending the previous one just off orbit somewhere else. Because again, after some years, they will all come back down to Earth one day or the another, and that will just cause a huge problem. Like, just imagine this, the space debris is coming down. We don't have an danger from asteroids, but these, so that would be really tragic. Like, we never thought about it, even though we can, like, that's definitely a thing. Like, we can think about it, but we did not do anything about it, and we just send them in the
Yeah.
space.
At the same time, there is happening. I mean, there is UK and Swedish companies that I spoke last time with the people, especially one guy that's coming. That's already. You can go and check it out. That episode we talked about collecting space debris of these satellites, because that is a problem. So we have private companies working towards that solution, where they actually, and I think Japanese companies working towards that,
Hmm.
where they catching these with the harpoons and with nets. It's like fishing.
Yeah.
So that's very interesting.
Yeah.
So they're already doing that, but we're talking about, again, bringing more attention to the people and making space accessible to the people. So with that, we have a problem of universities and students and schools right now are available to launch, let's say, cube satellites. which in most of
Yeah,
the
yeah.
times, like if they're going to be like 10 by 10 inch or 10 by 10 centimeters or smaller, because I had one of the guys on the show, Rifat Sharouk. So he created one of the
Mm.
world's smallest, CubeSats
Yes, yes,
also. So
yes, yes.
he's a great
The
guy. But
tiniest one.
exactly.
Yeah,
So, but we're talking about again the cube satellites that are about that size. So anything that size, it's not going to have a propulsion system that will help to redirect the
yeah.
course instead to avoid the collision. So,
Yeah, and
so
you cannot even detect these small things.
yeah.
As small it gets, it will be very hard to detect it, and it will be just coming so close. And what if it crashes into an astronaut or some other important space missions, more important than the currently that are ongoing? So that will just cause a huge problem. Like that's just a huge loss of money and time and everything else, just because of simple mistakes like this. Like we have to really think of a way that they're not causing problems.
Yeah. So at at the same time, we're thinking about saving, money, because I think that's an issue, because we're trying to about, saving money on the, equipment and all of these satellites, because I do understand they cost millions of dollars, and government, they're very careful about when they want to spend the money on what resources, and somehow
Yeah,
science is being.
which mission?
Exactly, and
Yeah.
science is always one of those, spending, budgeting pieces that they don't spend enough of, I guess. And they try to even lower the
Mhm.
cost. Which again, it's great that SpaceX can lower the cost for the rockets and make reusable rockets. So it's good that we go in that direction to make things reusable. But again, making it at the same time
Yeah.
smaller, because that's lower our cost too. But it creates more problems again with
Hmm.
collisions and everything. But so
Yes, yes.
other things that you talked about again in the future. So any astronomy events. So one of the events was Gemini's meteor shower. Again,
Yeah, yeah,
for the people who are watching this post, because this is happening tomorrow, 13th of December.
yeah,
So what about
yeah.
other projects like that where people can look up and kind of observe what's happening in the universe?
Yes, yes. So the next popular, I won't say popular, but the next best thing that will happen after Geminids would be something known as the Great Conjunction of the Jupiter and Saturn. Even I am so excited about it. Now, what's special about this thing is if you go outside on 21st night, 21st of December, if you go outside and if you're looking at where the planet Jupiter is, what you will realize is next to Jupiter is Saturn, and you will almost see this. Again, they are so bright, you can even say that these are two stars. But if you know that stars twinkle and the planets don't twinkle, and if you're able to realize like where is the Jupiter situated in your night sky, you will see that next to Jupiter is Saturn, and they are so close to each other. Like if your eyesight is not good, you can even say that that's just a single object. They will be so close to each other. In astronomy, we say that this is a conjunction, that two bodies are appearing from Earth like next to each other, and that's like a rare event. uh,
Mhm.
for Jupiter and Saturn, that happens every 20 years, but this is a special case where they're coming so close. They're coming like very very close, like a 1/10 of a degree, and in astronomical terms that's very close compared to the other bodies. The last time this happened was like 800 years ago. So that's like almost a century, not just century, like 8 centuries ago it happened. And that's like so much years. Like humans after, like before 800 years, they observed this thing, they observed this phenomena. And it has been 800 years since any human has seen this. So I think that's a really good thing about astronomy. Like these rare events keep on happening, and you can again can think like what would the people who were 800 years ago who were watching this, what would they might think, but they did not had that much knowledge. But because we have so much knowledge, like astronomers have already predicted that it will happen at this time and this date, and they will be this close. And then you can, maybe if you have a telescope and you can observe it even with naked eyes, you can go out and observe this, take pictures of this, because it won't happen again for many years. At least I think 80 years it won't happen. So that is like such a long time it won't happen. And the other thing would be near the end of the year it will be like I'm guessing like near the end of the year of 2020, after like 2nd January or 3rd January, near that time, there is again a meteor shower coming in, even better than Geminids. So in Geminids, what we have is we have 2 days, 13th and 14th, and we're trying to observe the meteors. But when it comes to the Quarantids meteor shower that happens in the early January, just in the first few days of the new year, they have like the number of meteor showers per hour is even higher. But that's just for very specific duration, just for a few hours. So if you're managed, like wherever you're living in the world, if your time, like if it's dark at that time when we are trying, when the earth enters into the path of the space rocks that were left behind, and if you're trying to observe the Coronet's meteor shower, what you will have is a sight that is even better than the Geminids meteor shower. So even if you miss Geminids, maybe it's just cold, or maybe you were just not aware of it, you can try for the Quarantids, because that is a really great one. I have seen both of them. Like I have seen Geminids and Quarantids, but I would say that Quarantids is just so much more, because you can see the meteors like more and more. Like it's just every few minutes you can see a meteor. Every few minutes is you can see a meteor. But that would happen for many days. That's just like either 2nd January or 3rd January. So that is something, yeah, like people can look up to at least these two events. And then again, yeah, near the end of December, there is again one more meteor shower, but that's not very it's not that promising. There are few meteors that will be there, but not that promising. Geminids is again very promising, and the Great Conjunction, as I told about, which is happening after 800 years, is again so rare. You can always say, like, that's two planets were so far apart, and now they're coming. And if somebody sees them through the telescope, what they will see is there's Jupiter, there's Saturn, and there are the moons which are visible. So it will be looking like so almost like a star cluster. There are planets, there are the moons which are so close. So I think it will be making for a great sight for astrophotographers, or just people who do stargazing or any of the stuff. So it's something to look up to.
Yeah, exactly. We're gonna see a lot of those great photos on Instagram, on all our
Yeah, yeah,
on
yeah,
all of our feeds. You're gonna see all the conjunction photos, and every one of
yeah.
these is gonna be just
Just
better
like
and
we
better.
had with Neowise. Yeah,
Say that
when
again.
Neowise came, it's like every when Neowise came, the comet Neowise.
Yeah.
So it's like everywhere the people who were not even into astronomy, they were like taking pictures of this comet, because this was visible with naked eyes. I even
Yeah.
saw it. So what happened is it just made everyone so excited. Like, okay, we can see a Neowise from our country. This is the timing. It is coming that close to us, so they could follow. And some people have given images in which they are taking a picture today, and after 2 days they're again taking the picture, but they can see a change in the colors of the tail of the comet. So that was really beautiful. It's like, because it was not that hard to see, people can see it with the naked eyes, and whatever photographic equipment they can have, they could capture it. So I think again the Great Conjunction will, because people will be just looking up, and they will be seeing all the different kind of images, like how close they were. And again, the astrophotographers will try to make the most out of it and give us the bestest of the pictures.
Exactly, exactly. So, I mean,
Yeah.
you being a space science communicator, I'm sure I'm not asking you enough of great questions to uncover basically what other things are people not aware of when it comes to that. So, any other subjects that you want to bring on about space science that people not aware of, but they should be knowing about these subjects?
Okay. Yeah, there are. One thing is, in when it comes to the whole space science, or at least the astronomy, what happens is there are new branches opening which have astronomy related to them. So first it was just astrophysics, and recently astrobiology. So these are the new, not new branches, but these are the more commonly known branches. But now astronomy is reaching into other fields, and they're trying to like make their mark. So it can be just like there is astrochemistry, but astrochemistry is not that popular. I have seen students and people who are astrophysicists, but I have not seen scientists who are astrochemists, for example. So what I would say is there are so many new fields happening in the astronomy. So they are just in the developing stage. They're not that popular. Maybe there are not that people who have who are known as astrochemists, but that's a field, that's a thing. People can be there. And the other thing that is happening, particularly in the space science thing, is the space exploration. So as soon as the I would say the deadline is coming to reach to the Mars. So just in next 5 years, if we are thinking that either through SpaceX or through NASA, if we are thinking that humans are going to the Mars, what the question comes is, what will they do? How will they live there? Who will be, which laws will be applicable to them? The whole concept of space law is something new that is just coming. I don't think much things are being done about that. It's not taken again that much seriously, because if nobody takes it seriously, it's like laws will be made in just a hurry, and whosoever is the first person to send humans, like whosoever is having the authority, they will just say, these are our laws. We have sent humans, and that's their mission, and they will just dig a hole there. You cannot stop us because those are the first humans that have gone. But what if like digging a hole on Mars can, can cost us something just 100 years later? So we will have to really think about the whole thing of space law, because it's just really so important. And again, like the I think why we have space debris is because nobody really thought it through, and that's why we have space debris. Because if other countries were more aware of these missions, they would not have taken these steps. Maybe they would have something like what to do with these things. So similarly, if we just put something, if we send humans to Mars, maybe they can create some garbage, some trash, and if nobody takes care of them, that will just cost us many years later. They can, even the resources, like if they're going there and if they're trying to collect the resources, like they will go for the best resources, and if they come and they sell it on Earth for who knows the exponential price, so it's like they will have an unfair advantage. But if we have all of the countries come together and they say, even if our our space missions to Mars is not launching this year, but after 10 years, we want to make sure that when we go to Mars, it's not as if everybody has taken everything out of it. Like there's some space for them, even if they are late in the whole space game and reaching to the Mars. So I think the country should be more aware, even if they're not sending missions to Mars currently, even if they have like deadline of 5 years, 10 years, 15 years, they should at least all come together and make some rules, so that nobody is at least exploiting and everybody is on the same level, like they have a same page. So nobody is like exploiting just because they reach there first.
Okay, so that's very
Yeah,
okay. So yeah, more rules and regulations, please.
yeah. Yeah,
Got it.
because
Yeah,
in space we don't want people just doing anything randomly, because that's not a good thing. It's happening everywhere in the politics and in health and everywhere else, in even education. But at least when it comes to these things, I think people should look at the bigger picture, and they should try to make the rules which are like good, not just for money or those things,
yeah.
which are really good, which will
Yeah.
help the humans.
Yeah, so that's very interesting because yeah, we definitely need rules and regulations when it comes to again launching
Yeah,
the satellites in orbit. So it's very interesting approach
yeah,
because like if we're talking about colonizing Mars and like personally,
yeah,
uh, it's a great idea. Like some people are saying we should not colonize it. We should just go make a mission, test the soil, or do whatever with the
yeah,
planet and just come back. So everybody has different
yeah,
thoughts,
yeah,
and of course, there's all these planetary
yes,
protection
yes.
organizations that now coming up to make sure that we're not going to build the moon base or we're not going to colonize Mars. So everybody has
Yeah,
different thoughts on should we do it, should we not do it. But at the same time, if we're not going to do it, we're talking about another couple billion probably years until our sun will run out of the fuel, and eventually we will extinct. At some point.
yeah,
So
yeah.
so what do you
We
think?
will have to colonize
Yeah,
the other planets, and
yeah,
we will have to eventually go out.
yeah,
But for that, we need some some regulations, so that that's at least a smooth process. We don't
yeah,
have to really exploit something, but we have to experience. We have to gain that exposure, like how to travel to the different bodies. So how to travel to Mars, how to live on Mars, how to live in space. We have to really get that experience before we can make travels to the other star systems. But what we need to do is we have to go there as a collective species, not just representing a company or
hmm,
a country. That should not really be the case, but in general they should go, like all of the humans are going, so humanity is going to the Mars. It should not be like
yeah,
SpaceX is going to the Mars, so that should
yeah.
not be the case.
Yeah, exactly. So, do
Yeah,
you think, again, looking currently what's happening again with the COVID and all the political stuff and everything that's happening, different religions, different understanding, different views of the world. Do you think it's possible for us one day to kind of, and of course, in the beginning stages, I'm talking about a handful of people, let's say 1,000 people that can come along together with the same kind of view of just exploring space and just living as a community and understanding each other and supporting each other and kind of living on completely different views. Is this possible for us as human beings?
yeah, that is something I cannot really relate to right now because the current situation in different countries, the situation is so like getting to a situation which is not really good for the humans. So everybody, all the countries are trying to have either like fight with other countries or trying to be better and show the other countries like we are better than your country. So like there is so much tension between the countries itself and the people. Again, the people who are living inside the country, even they are trying to become more and more independent, and they're not focusing upon building relations with other human beings. So they are just, trying to be just independent on themselves. There is not that ecosystem where we can, like, there are no locks at all in our room, and we can just, go outside and we can come back. So that doesn't really happen, because there is shortage of the resources that we have. So if we stop exploiting the resources, then there will be plenty of resources for everyone. So if the exploitation part, somehow we handle that part, like, again, we have more and more rules that, like, there should not be just exploitation. All the companies are just, are kind of managing between the profit and the losses, and they're not trying to exploit anything. So that will encourage to an ecosystem where humans are living more friendly, because there has been evidence that the humans who were living thousands of years before, when they first settled in, it's an evidence when we say their, their bodies, because they can really tell us about how the health was there. And if you look at this data, they show that everybody had the same kind of health. So nobody was really a king, a peasant, a worker, like somebody is in force. But even there, some people might be powerful, but still they shared the same kind of food, they shared the same kind of things, because they did not had so many resources to exploit. Just just few things they will just share with each other. Even the when humans first started settled in, all of their like houses and things were very same. But slowly and slowly, some humans like tried to break the ladder and just have bigger homes, bigger resources, bigger houses. So this has just shifted us in a direction that we want more and more. We don't care if the other people are like suffering, or if they have less food, if they have less security of things, if they do not have right. We're just making sure that we live perfectly fine with ourselves, because even we are so insecure. Like, we do not know, if we do not work, if we do not lock the door, somebody will just something will happen in our home. Even if we don't steal it in other homes, we are so insecure that it can happen in our home as well. So I think that there needs to be a very great shift, because if we go to Mars, we don't want to have like these kind of problems again, because we don't just want to make Mars the next Earth with the same problems,
Yeah.
but we want to go there to become better, understand our species better. Like, when there are such harsh conditions, we are going to a planet that is not suitable for humans to live. When we are going there fighting such a great challenge, we don't want to find small challenges, just fighting over some small resources. So that should not happen. When we are looking at the big picture, we should even look at the big picture in the real sense, and not focus on the small things, and try to decrease our differences and live more of like how the human species used to live so many years ago, without exploiting the other humans or the other resources that we have.
Exactly, exactly. That's a great point because
Yeah.
again, we're coming back to the same point, which is rules and regulations. Which
Yes, yes. Because
because
because I'm saying everybody has already, like, this system with the politics
yeah,
and with how the industries have came up. This is already exploited so much, but the space exploration is still in the initial stage. We have not colonized the planets around us, and there's no hope. So the situation is not like that. It's still in the initial stage. We have only caused some few tiny problems that can be taken care of if we just become more aware, and if we all come together and
yeah.
try to,
Well,
like,
you see,
use some time and invest in these things.
you see,
So those things would be much better.
what
Yeah.
I'm afraid of, sorry for interrupting, but what I'm afraid of that there are so many rules and regulations that nobody in politics will allow. Who do you think will allow and say, okay, fly to Mars independently with no rules and regulations. You don't give us any feedback. You do whatever you want. What's the chance of that happening?
Yeah, next to zero, next
E-
to zero. it,
Exactly.
it won't
So
happen.
exactly. So we're talking about carrying what we have in here, carrying the same rules, same principles, because we are dreaming about this
Yeah,
kind of free life that we want. Because now we're
yeah,
talking about,
yeah,
again, because now look, if we look very simply, because even like if you guys have read any business book, it says like the
yeah,
tax code is written for the rich. And look,
yeah.
so in this age, you
The
either
rich will
poor.
keep on getting richer. Yeah.
Exactly. So the people are
Yeah.
divided really like a lot, and there is so many rules and regulations like for people to be free and to do what they want, and like it's rule on top of the rule. So it's very hard, and
Yeah.
that's
Yeah.
why the process is so slow. So like, and that's why I personally think it's gonna stop us from surviving or accomplishing big things in life, because we're talking about space projects which is like it's crucial. We're talking about life or death situations, and we're talking about being not enough funding, when actually we created a system that we can print as much money as we want, but we're talking about there's not enough money for these funds. so
Yeah.
so
Yeah.
we're talking
Yeah.
about
Yeah.
something, it's very like confusing, like why is these things happening? Because so people call it different names, but we're talking about just politics and rules and regulations getting involved into this. So, which I think
Yes.
it,
Yes.
it
Yes.
will involve a lot of great shifts, which I don't know what it's going to take. If it's going to take an asteroid to hit us, and then we're all going to be, okay, listen, we need a brand new
Yeah.
system, or it's going to be something else, but it has to be something.
Yes, yes. One thing that is, I would say, a ray of hope is the international collaborations that are happening when these missions are being sent to space. Because if two countries are not talking to each other, they're ready to fight with each other because of
Yeah.
whosoever the political leaders are. Because the scientists are saying, okay, we need to, let's suppose we need to go to this asteroid because there's, let's say, diamond there, and we need this country's help, and we need this other country's help. So even though they're looking at the money, the scientists can show that they can collaborate really well with these other countries, and at
Yeah.
least that is something very optimistic, because all of the countries have different issues. But when you look at the missions which have international collaborations, either like the Event Horizon telescope, where so many different scientists came from across the world, even though the countries are not on friendly terms, at least the scientists are trying to bring out the best of us so we can collaborate with other people. So similarly, maybe these the hope will come from the bigger and bigger projects that we have. But currently, if if SpaceX can do everything, it doesn't need help from any other country. So if there are organizations, or if the companies try to similarly collaborate with the other companies as well, and if they all go together, not from the US, but they're going, let's suppose, from the other countries as well, maybe it will have a pressure to make the rules and regulations in a way which like supports all of the countries, not just their single country. So more and more collaborations, because some rules are good, some are bad, but if we all collaborate, maybe we will just have good rules left which help us to move go forward in that direction at least. So more
Exactly.
and more collaborations, I would say,
Exactly.
and more rules again.
I do, yeah, I do agree
Yeah.
1000% with you of making collaborations, because I talk on a podcast all the time and I tell to the people, because I will tell you right now and
Yeah.
today exactly the same thing. Go and get in contact with Rashmi and talk about any space project. If you have any personal interest about that, just making those connections and these conversations happen is very important. But when we look at the scientists and you were talking about making these collaborations, look, scientists doesn't care about one thing, about money, because they're
Yeah,
looking to
that's
add.
that's the best thing about them.
Exactly. They don't
Yeah,
drive fancy cars,
they're like,
simple
yeah,
people. And they look into add
they want
value.
to drive the
Yes.
fancy data. They want to get the right
Yeah,
data, the most accurate data in the entire world. They want to
exactly.
spend just so many nights, but they want to get the right data. If it's an astronomer, they want to make sure that the telescope is the best one, it's situated at one of the best places on earth. And if somebody is making some fancy restaurant or mall is opening which will be causing light pollution, they will go to all the ends to make sure that this mall doesn't open up. They'll be like, no, I don't want light pollution there. So that is something when they try to come into the other part of the world, and they try to like come in the policy making, or try to show their authority and their knowledge that no, you should not open this, you should not do this, because it will be coming in the way of us doing science. So yeah, but we don't really need that sort of problem. Like if the people who make the policy, they already take scientists into the account, if they take their advice and then they make the decisions, I think that would be even better. Like the scientists don't have to lose their nights on these things, but they can lose their nights on getting the better data, not on these things like yeah, this will hinder with my data, or this will do something that is not good for the project that I'm working on for so many years. So scientists have better things to do. Maybe that's why they do not focus much on these things. But what politicians they can do is they can again collaborate with the scientists and with the other people to make the decisions which are better, like which are scientifically accurate. So even if some country is trying to find a way how to stop or how to get back, like how to do something against the global warming that is happening, the climate change that is happening, the best bet is to talk to the scientists who are working on this problem since years and talk to them like what can we do about it, rather than talking to a politicians like how much money do you see in this. So the people who they talk to, that should really change, and scientists should be more and more part of all these rules and regulation they are making, because their data is the best. Like science cannot be easily wrong if like so many facts are attached to it, people are doing it since so many years.
Yeah.
If they have shown the data that yeah, this will happen, even if it's profitable or if it's making loss, that doesn't matter. It's just like that will happen eventually if the scientists have declared.
Awesome, 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 awesome. So, what about your personal, work? Again, we talked about it again. Current projects that you're in work, involved with, and some future projects as well. So, from your
Yeah, yeah.
personal take, I mean, what type of, value or a footprint or a legacy that you want to leave with your personal work?
What I want to leave, so I want my work then again will be around the observational astronomy. So even though I have interest in things like studying how a galaxy morphology is, how the galaxy that we see, how it was so many years ago, how the universe will be after billions of years ago, will there be another universe? So I have all these questions. But again, what I feel is to get inspired to ask these big questions, you should have the other experiences, the real life experiences as well. Because if we study all these things in the books, if we do all these calculations, we should have a way in which we can visualize these things, because in astronomy you do not have a lab and you cannot do things with your hands right there. You have to look at the night sky, you have to just observe the things that are happening. So one of the things that we can make it more accessible is just giving the best night skies to the people and giving the knowledge to the people. So as I said, if somebody wants to become an astronaut in India, they cannot look up to someone. And if they want to, let's say, suppose if they want to study astronomy, there are not that much institutions. And then the other thing is, there is no astronomy in the popular media. So what I want to do with my work is, at least like I'm doing science communication either on my Instagram, or if I'm making YouTube videos. So I don't want to make another channel and just talk about the things that everybody else is talking about. I want to talk about those things, and I want to people learn from whatever I'm talking. But and at the same time, they should think like this is like possible for other students or other people who thought that astronomy, they cannot study astronomy. Astronomy is for someone else, not for people in India. Or astronomy is for people who are very smart, or astronomy is for people who can stay awake in nights, because the stars are there in the night. So there are so many things that go studying astronomy, and I want to break at least those type of stereotypes, that even if you have not studies in your school curriculum, astronomy is there. Institutions will happen. And if you want to get the knowledge, if you do not want to be persuaded with the pseudoscience that is shown on the popular media through astrology and all those things, you can try to follow science communicators that are there, or you can try to follow the astronomers. And even if the astronomers are not able to reach the public, I can make sure that I bring their work, I highlight their work through myself and through my science communication skills, and bring to the people of India. Because if we are not aware of what is happening in our country, that won't be a great thing. So focusing on the astronomy in general, but then again, I want to make things better in India itself, because I think India is a bit behind compared to the other countries, if it's in science communication, if it's in public outreach, because there are not many private planetariums. Because there should be a planetarium in every state. I just think that there should be a telescope in every school, in every college, but there's not. They have a microscope, but they don't have a telescope. Like, why is that there? Biology is obviously popular, but again, astronomy should be so popular because it's the ancient science, just like health. So I think that things like just having a telescope in the school, because it's, even if it's not a need, it should be there to make them inspire the students. So all these kind of things, I want to work upon them. And again, I want to do that with yeah, making more and more doing more and more science communication and doing some public outreach. So I cannot do that currently because I cannot travel to those locations, but I have done in the past. I have I have gone to the people and I told them about, okay, this is a Gemini meteor shower, so it happens because of these reasons. Your wish won't be counted because it's not a shooting star. Why it's not a shooting star? So telling them about these simple things. If I'm telling them, okay, this is the Pleiades star cluster, and there are so many stars, and if I'm telling them a story, they can relate that to it. So they won't think that we do not know what the stars are there for. They won't feel so lost. They will be like, okay, these are the different constellations, just simple things like that. This is a planet, this is a star, these are the different constellations, and this is astronomy. Just like we have health, we have fitness, we have makeup, we have so many other things. Astronomy would be more accessible and there won't be a much stigma around it or pseudoscience related with it. So I just hope that more and more people get involved in astronomy, just because that can be a bias because I love astronomy so much. But that is something I really hope that astronomy becomes more popular, not just in India, but everywhere else, but specifically first in India.
Beautiful, beautiful. And that's
Yeah.
I love the fact that you're working on that and you're dedicating your own personal time and resources. And because look, it's very important, like what you do. So big thank you again for you for putting the time and making those things happen and bringing more awareness to astronomy and what's happening in space and different space projects and why people should get involved. Because as I
Yeah.
said, look, we're about to destined to extinct at some point. So
Yeah.
if we don't plant these seeds right now, for the future generations, because we're talking probably a couple of 100,000 years in advance, that we probably
Yeah.
will be able to come up with some sort of a, crazy propulsion light year speed type of system that we can travel, interstellar dimensions. But look, we have to make those seeds grow, from today, from this conversation.
Yeah.
So
Yeah.
guys, for you, I hope you got some really good data from this conversation, because that's what it's all about, right? Getting better data. So, and last thing, guys, that you wanted to ask you again, if you pass this episode to your friend, and could be any friend, just make sure to pass this episode to them, because more people need to be aware of about what's happening in space and again, astronomy, different again space projects that we talked about today, and how people can get involved with those through community projects, which of course a bunch of those will be linked in the show notes. So again, a lot of those will be probably for India market as well. So make sure to read through those and get in contact with Rashmi personally and ask her questions about space, about some projects that we covered today. Maybe have some other topics, and just make a connection and become friends on social media as well. So, and for you,
Yeah.
Rashmi, again, big thank you for coming over today and sharing your personal passions, journey, and reasons why people should explore space and get involved with astronomy. So thank you so much.
Yeah, I would also say like thank you for having me. Like we talked about a whole range of things, not just relating to astronomy, but even exoplanets and alien life and making space laws and all those things, which are the big topics. But we should again, we should talk about the science, but we should also talk about the things which we cannot really see currently, but which will happen eventually. And yeah, again, as I said, making this conversation will at least make the people aware, like there is something like this, it can happen, so we can be already prepared for either the good or the worst. Whatever is going to happen, we can at least be prepared and we can be aware. So thank you for having me, and we could have such a good chat about all these things.
Thank you, thank you. So again, thanks Rashmi for your time. And guys, as I said, make sure to pass this episode along to your friend. And as always, I'll see you next time. And don't forget, keep exploring.